Hello and welcome to Programming Rush. Today in this video we are going to discuss the problem trapping rainwater. So in the problem it is given that we will be given n non-negative integers representing an elevation map where width of each bar is 1. Now computing how much water it can trap after raining, we have to compute that. So this is a problem of level hard, but we can solve it rather easily. So let us see an example of the given problem. So in the given problem, we have the example of with heights of the walls as 0, 1, 0, 1, 0 like this. Okay. So now we can see that here we can save the maximum water between two walls because this is the height of wall 2, okay, and this is the height of wall 1. So between two, which one is shorter? The height of wall 1, and the water at most can be stored till this level. So here we can save 1 unit of water. Okay. Now coming to the next part. Next, after the wall 2, we can see another wall at a height of 3. But between these two, the height of this wall is of 2 and this wall is 3, but minimum is 2, and the water can be leveled at this part. So this is not a unit section. We have 3 bars, means 3 unit length. Okay, and for each unit of length we have different wall sizes. So for this unit we have an elevation of 1 unit, so the total water that can be saved is 1. Next we have 0 elevation, so we can save 2 because the maximum height of water here is 2. And next again we can see that the height of water that can be saved is of 1 unit. Now at last we have a height of 3, but we have a here of a height of 2 unit. So the maximum water that can be saved here is of 2 unit, but the elevation is of 1 unit, so we can save here only 1. So the sum of this is 1 plus 1 2 1 4 plus 1, which is equals to 6, and this is the answer. And we have to do this in this problem. We have to do this only. We have to find the maximum water that we can save. So let us see how we can do this in the next part. So here let's see the approach that we are going to take it. So first of all we have to make it clear that a wall with a longer and shorter, the water will be at most till the shorter wall, not the longer one. This is one thing. Okay. Another thing, that is we have like this, some walls like this. Okay. Maybe there may be any height. Okay, this is not to this given example. They may be of any height. Now we know that we can see that the water can be stored at this height. Okay, so we can see that the highest wall is of this height, and after that the second highest is this. The water can be stored up till the height of this second highest wall for this section, and we are going to apply the same thing only. We are going to find the highest wall for this wall and check and make the maximum water level that we can save. And for then each of the values, each of these indexes, we are going to find the water level that we can, water units that we can save. And finally we are going to return the answer. This will be our very straightforward approach. Let us see how we can do that. Now what we can do, we can save the maximum height from the end till the first. What is the maximum height of the walls? So for this array we can create a max height, okay, like this. For here we have 1, then the wall height is 2, so we can do it like 2 2 2. Now we have the wall height of 3, so we can continue it 3 3 like this. Okay, so this is the maximum heights of the wall. Now what will be the height of water for this section 0 and 3. Water height. What will be the water height? The water height will be for this section is 0. Why this is 0? Because this wall length is 0 and this wall length is 3. So which one is the minimum? First of all, we have got the maximum height of wall that we can get at this index. As you have seen, what is the maximum height of wall that we can get at this index after it? This one. This may be 3, this may be 2. So maximum height of wall is 3. So here it applies the same. So minimum applies here. Now here the minimum is 0. So we have written here 0. Next, for next index we have the maximum height 3 and the wall height of 1. So the water height level increases and the maximum water level that can be achieved is 1. Again, for the next index we have the height of wall as 0, bar or wall, what we can say, build. But we have previously max water height 1, so we can keep it. So we need to maximize this, okay, until the given index. For this we have the height of water level 2 because we can see the height of wall. Next, this will continue to 2 until we get the highest height length of wall 2, and at this index we have the same wall length, and this is the where we can save no water because we can see that here may be 0 0 0 0 0 0, but here no water can be saved. So here we can write 3, okay, the maximum height that we can gain, the water height level, but the height of wall is also 3, so the net water saved is 0. Now at next index it will be 3 like this. Why? The minimum, again the minimum, the water level that can be stored here is not 3 but 2. Why 2? Because between we have the maximum height of water 3, but the height of this is becomes the maximum height that we can get is 2 and the current index is also 2. So we are going to keep it as 2. We will get it as 2. For this index it will be like 2, then again 2, and finally it will be 1 because the maximum height that we can get here is 1 and also the index is 1. So the comparison becomes between this and this, not the previous ones are not kept in record. Means previous ones are kept in record like this but not in this part. So let's see how, and now what we're going to see, how to save the water, means calculate the water. So the answer will be like this. We are doing it by array, but at the implementation we are going to do it with one variable only. So here the height is 0 and the water height is also 0 0. Here it is 1 1, so 0. Here it is 0 and 1, so it will be 1 0 1 2 1, then 0, then 0, then 1, then 0, then 0. And what is the answer? 2 plus 1 plus 1, and the answer is 6. And this is what we need to get. This is our answer. So now let us see how can we implement this in code. The approach is very similar. Simple, that we need to calculate the maximum suffix array, and for that we need to calculate the water height, and then we are going to at each loop we are going to find the height of water that we can save. So let us implement this in. Now we are going to implement the code. Now I am implementing in C++, but we can implement in any language. So now let us see the height of the size of the given array. Okay, we will be having an variable answer to store it, which we are going to return initialized to 0. We also have a array as vector int max height of length n. Now, and a variable int prefix max. This will be the maximum height of wall we got till now. Maximum height of wall that we got till now. Okay, and it will be initialized to the starting height of wall or the building or bar, what we can say. And the maximum height, max search, that is the suffix array. At the last index, we are going to initialize it with the last wall height, that is a height at the last index. Now we're going to run a for loop. And then at every loop we are going to do like this: max h at high is equals to max of max h I plus 1 and the height that we have now. Now we will run a for loop from int I equals 0, I less than n, I plus plus. And here we will be having a prefix max is equals to as max of prefix max comma height at that current index, and the answer will be equals to minimum of the prefix max or the suffix, that is max height at the given height at the given index minus the height at the current index, because there will be a water level but there are also going to be some elevation that we can see here, so we need to subtract this. Okay, and finally we are going to return the answer. I think the code is alright. Let's run the code. Let's run all the example test cases. Yeah, the output is correct, so let us run it. So yeah, the code run successfully. So thank you for watching this video. This was the solution from the problem trapping rainwater. This was a hard type of problem, but we have implemented using the suffix array, which made this problem very easy. And if you like the video and like the algorithm that we followed, please like this video and subscribe Programming Rust for more such videos. Thank you.